Okay, guys, we are going to look at section 5.3, and 5.3 is using the side angle side congruence theorem. And there are going to be a number of congruence theorems that we learn in this chapter. The side angle side, or SAS, is the first one. And if you recall in the previous video, I talked about the idea that the definition of congruent means that all sides and all angles must be equal in order for triangles to be congruent. Well, these congruence theorems, they're a little bit like shortcuts. So they're ways that we can prove that two triangles are congruent without having to prove all three sides and all three angles are congruent to each other in the different triangles. So this first theorem, which is called the side angle side, states that if you have two triangles that have congruent sides and the angle that is included, so that actually means that it's the angle that is made by those sides. So it has to be the one that's right in between those sides. If they're congruent, basically that means that's the only way that those pieces can fit together, and that is enough to be able to say that the triangles are congruent. So if you look up at this diagram up here, it says that triangle ABC is congruent to triangle DEF. And notice that the triangles, it's almost like they are reflected off over that dotted line. So you always want to make sure that you're naming them correctly. So it goes from A along the side with one tick mark to the other one, D along the side with one tick mark to the other one. So that is side angle side. Pretty straightforward, actually. So for this next page, we're going to do a proof using the side angle side congruence theorem. So it'll be a two-column proof. So on the left, we will have our statements, and on the right, we will have our reasons. So we're going to start with what we're given. So I'm given that side BC is congruent to side DA. So you can see how those tick marks are on there. That's great. It also tells me that segment BC is parallel to segment AD. So I'm just writing down that those are given to get them sort of in my proof. Notice these little triangles. It's really important to for you to remember that just because there are arrows, it doesn't mean those sides are congruent. I've had some students make that mistake in the past. So if they each have one arrow, that's only saying that they're parallel, and that's why you have those additional tick marks right here to say that they're congruent. And remember, we want to use this as our given, not info from the diagram. It just happens to be in both places. So what we're going to do is we're going to look up here and like, oh, we know we're going to use side, angle, side. And I already have one side, and I have to look at my diagram and think, why are they telling me that there are parallel sides? Oh, that's because we have alternate interior angles. I'm going to put a 1 here and a 2 here, and you are always welcome to use 3 letters to name the angle. But in this case, by putting the 1 there, I can say angle 1 is congruent to angle 2. And the reason for that is the alternate interior angle theorem. And remember that that theorem says if you have 2 parallel lines cut by a transversal, that means that the alternate interior angles are going to be congruent. So that's good. So now I have a side that's congruent and an angle. And now I just need to get another side. And if you recall, I'm going to see if I can get my highlighter to work here. There's a side and a side and a side. And you can see that those angles are in between them. Maybe if I draw it over to the right, because I just want you to be able to see it. So we have this one, and then if I draw them separate, we have this one. And so they gave us that this was congruent, and we just said that these angles are congruent. And so we need to figure out a way to say that these sides are congruent, which we know. We know that we can do that because of the reflexive property. And, or you could write it this way. Some people like to do this. So that's reflexive property, but there are a couple of other options that I'm okay if you want to put it down. You could also use shared side, or you could use same side. Any of those 3 options are okay. And it's a good reminder that whenever you have a shared side, you just always want to look for a shared side. So always notice if there is a shared side. Because that is going to make a big difference. And now, I hope you can see that we have enough. We have this side is now congruent. And so I can now say what they're asking me to prove. Triangle ABC is congruent to triangle CDA. And the reason for that would be SAS. And you can write congruence theorem, but I'm perfectly okay if you just do SAS. So that's it for this slide. So now we're going to do another example using SAS. And this one's good because it has a slightly different type of diagram. We're so used to seeing just triangles by itself. So this is a good example of that. Let's look at what they've told us. They have told us that QS and RP pass through the center. That's really important to know because if I didn't know that they pass through the center, then I wouldn't be able to say that these segments are congruent. Because remember, the definition of a circle tells you that it's a set of points that are equidistant from the center point. So that means that we know that MS and MR and MQ and MP have to be congruent. So let's write one of our 2-column proofs here. So I have my statements and my reasons. And even though it's not written as given, we know that this information up here is given. So I'm going to make it into a given. So I'm just going to say QS and RP pass through center M of the circle. And you actually need that information there in order to say that those other segments are congruent. But what's nice is I can automatically go right to it. I can say that MS is congruent to MR, which is congruent to MQ, which is congruent to MP. And that is all points on a circle are equidistant from the center. And your wording doesn't have to be exactly like that, but you do need to sort of have the general idea of that same information. So because I know that all of these, 1, 2, 3, 4, they're all congruent, I'm pretty close to being able to say that my triangles are congruent. And all I need to do is find an angle. And of course, we have our vertical angles that are right here. And so I'm going to, maybe I'll put a number in there. So that's angle 1, that's angle 2. And so angle 1 is congruent to angle 2. And that's VAC, vertical angle conjecture, or vertical angles are congruent. Just remember, you're not going to do vertical angle definition. And our last statement is, and there's a number of ways you can name these triangles, but I'm going to say triangle MSR is congruent to triangle MQP. And my reasoning is side, angle, side. So here is one that I want you to try. And notice it says prove. So you're going to have your statements and your reasons. And then what I'm going to do, guys, is I'm going to pause like I did on the other video, and I'll do it out. And then when I start the video again, you will see the worked out answer. So good luck. Okay, guys, there is the worked out solution. And I want you to notice what I've put over here on the right, because there's a lot of information up here that was given to you. And sometimes you're given too much information. So I want you to always try to only put the necessary given information in your proof. So I put it all in there and labeled it so that you can get a sense of that. Here is another quick example that we can look at. Hopefully you can see, I'll make that a little bit bigger. So what can we conclude about triangle PTS? And sometimes it's helpful to outline it. So PTS and triangle RTQ. Notice that they're sort of twisted in the middle. With that, we have that one and that one. They're not exactly the same. But remember, we can always add our numbers, and we know that angle 1 is congruent to angle 2 because they're vertical angles. So what can we conclude about those triangles? That they are congruent. And we know that because of the given information plus this leads it to being side, angle, side. And there you go, guys. There is your little puzzle for this lesson. You want to fill in the magic square, and you're going to use each of the digits 1 through 9. You'll only use them once, and you need to fill it in so that each row and each column all add up to 15.